Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 137 called the single number 2. And for this challenge, given an integer array of nums where every element appears 3 times except for one, which appears exactly once. Find the single element and return that element. And we must implement a solution with a linear runtime complexity and use only constant extra space. And for this example number 1 right here, we have the input of nums array, which is consisting of 2, 2, 3, and then 2. And the only thing that we know that 3 is the only one that appears only once, other than the rest of the array components, which is all 2, appears 3 times. And the output result, we have to write it as the single answer, which is 3. And for this example 2 right here, we have the nums array of 0, 1, 0, 1, 0, 1, and then 99. And we have the output of 99. It's because all of the 0 and 1s already been write out, and the only thing remains, which is single, is the only number of 99. So this is the output that the function is looking for. And for the constraints right here, we have at least one number of the inside of the nums.length, which is the length property, which is denominating the array elements, and we have the maximum value of the 3 multiplied by the 10 with the power of 4, and that is the maximum value inclusive the most value, and the least value is at least one element inside the nums array. And for the value, which we are not considering this part, but we still consider this part because it is negative 2 with the power of the 31, which is the value is possible to be a negative value or anything that below the value of 7. And so that is the every element, and the maximum value is in a range of the usual integer, which is the 2 with the power of 31, and negative 1, which is the maximum value possible of an integer data type. And each element in nums appear exactly 3 times except for one element which appears only once. And let's solve this out, but before that, let me do a little drawing about my thought of process about what we are trying to use here. We can use the bitwise operator, or using converting them into a binary, which is the value of 2 right here, which we can convert this as 0, 1, 0, and then another 2, which is 0, 1, 0, and the 3, which is the, and we have the value of 3, which is 0, 1, 1, and finally the value of 2, which is 0, 1, 0. And since it is a little bit different, slightly different from the previous challenge, which is the yesterday's challenge, then we need to write out the all of the 2, which is the same binary as this one, and only return the 3, which is the binary 3 right here with the binary representation of the 3. And to do that, it is not simple for us beginners, but I have one solution that I created myself, which is not really impactful for this challenge, but at least it solves the challenge itself. And it takes a space complexity, which is using a hashmap variable called the hashmap, using the hash with the h hashmap, and we are storing every value as we iterate over the elements of the nums array, which is the 2 right here. We are getting 2 as the value, or as the key, which hashmap with the consisting the key value pair of numbers and the value, which is also numbers. Then we construct this new hashmap, then we store the key of 2, then we store this as the value of 1, and on the second iteration we have the value of 2, then we are adding the another 1, which is considered 2, then we are assigning 3 as a new key because 3 is not registered anywhere inside the hashmap constant. Then we can add 3 as the key with the value of 1, since the 3 is appears only once, so the value is 1, and another 2, then we insert 2 as another value of the existing value of 2, and we have the result of 2 with the value of 3, and we have the key of 3 with the value of 1. So on the left operand is considered the key in the hashmap term, and with the colon, and then it is representing the key, and after the colon, which is on the right hand or the right operand, which is the value. Hence the name is key value pair or KVP. So this is the basic principle of the hashmap. Then we can just, after using the first pass right here, which is the first traversal of the nums array, then we need another second pass or the 2 passes to iterate over the hashmap as the iterable array using another for loop to iterate over the key value and pair to see which one has the value of 1. Since the 3 is the only one that has the value of 1, then the key 3 will be returned as the answer right away. So to implement this, I can simply use the constant of the answer map. You can name it something else other than answer map, whatever. I'm using the TypeScript. I forgot to tell you that I'm using the TypeScript as my language to solve this out as the tutorial. And if you want to use something else other than TypeScript, then go ahead, I encourage you to do so. And we have the function of the single number right here, with consisting of 1 parameters, takes 1 parameters of the nums, and this parameter is in the form of array of numbers. So the expected output is in the form of number. So we have the constant of the answers map, and we can declare a new hashmap constructor, new map, and consisting the value. Since we are using TypeScript, then we can define the key as the number and the value as the number. And we don't forget to use a parenthesis because we are using the new map constructor, and inside of these angle brackets is the data type, which is the key, and this one is the value. So that is the key value pair, and we need to iterate this with the first pass using the for loop to iterate over the nums array to register all of the elements of the array as the key value pair to see which one has the value of 3 and which one has the value of only 1. So we iterate over the nums array using the let for let I is equals to 0 as long as I is below the nums dot length with the property of length, and then I plus plus. And after that, we need to register our element inside the answers map using the answer map dot set using the set method. Then for the key right here, we can insert this as the current elements of the array iteration using the nums of the current I. And for the second parameter, we can pass in the value, but before we pass in the value, we need to get the previous element if it's the previous key value pair if it's already been registered before. So that way we can, let's say we already have the first 2 right here with the key value pair of the state of 1, which is the value of 1. Then for this another 2 right here, we need to check if the previous 2, which is already registered as the key 2, is already has 1. If it is, then we can add this by 1. If it is not, which is on the first iteration, on the situation of the first iteration, then we can just assign this as the value of 1 right away. Then we can simply use the nullish coalesce operator, but before that we can use the answer map.get, getting the value of the key based on the key of the nums I. And if we happen to cannot find this, or it's not found on the answer map registration, we can simply use the 0 using the nullish coalesce operator or the double question marks right here. Then besides the parentheses, we can add +1, and that way using the console.log should return the answer map with the key value pair of every elements and their occurrences count. Then we can simply return 0 as our placeholder for now. So let's run this. What is the console.log output? And we have map of the 2, we have the key 2 with the value of 3, and we have the key 3 which only 1 occurrence happen. So for the case 2, we have the map which has 3 elements. The key 0, we have the value of 3, and for the 1 we have the value of 3, And for the 99 we have only the value of 1, so this one we need to return this key based on the value of 1. So to do this, we can use another for loop to iterate over the answer map using the constant of answer map. We iterate over the constant of the answer map hashmap. Then before the constant, we can use the destructurization of the key and value pair. Then for the console.log, we can generate every key and value pair of the answer map right away. Here's the console.log, and in the console.log will print all of the registered key and value pair. We have the key of 2 with the value of 3, we have the key 3 with the value of 1, just like on the map representation, but this one with the for loop. So we can just use an if check. If the value is strictly equals to 1, then we can simply return the key right away. And what happened to the return 0 right here? It is only as a formality to return the value, but it is already called by the for loop right here of the answer map, because the constraint is already stated that each element in nums appears exactly 3 times except for one element which appears only once. So that is the constraints saying, and we can just return this right away. It will be eventually return the key, and it will be catch 100%, and the return 0 is only as formality because the function of the single number is expecting a number as the output. So this is just a placeholder. So let's run the code and submit this to see if it really works. And we have the runtime of 5 milliseconds, and the analyzing complexity, we have the value of the complexity of the time complexity of logarithmic complexity and the space complexity of ON, which is the logarithmic complexity. And we are placed on this part, on this graph, and most of the people already solve this on my graph right here. But I want to show you another way to do this effectively using a bitwise operator to convert this as the binary. And we can just declare this, we can delete everything, and we can pass in the let variable called the result, and we can initialize this as the value of 0. And for the integer 2 right here, we have the binary representation of 0, 1, and 0. So that is the only 3 digits of binary representation from the right. 0 right here, which is notated as 1, and this one is notated as 2, and for another 0 is notated as 4. And since it is 2, then the 1 right here is activated with the value of 2. So this is the binary representation of 2. What about the 3? Let me refresh you about the 3. The 3 is notated as 0, 1, 1. So the right side is 1, and shifting to the left is 2, and another one is 4. Since it is activated, they are activated 1 and 2. 1 and 2 will be added, and the result will be 3. So that is the binary representation of the integer 3. And the integer, as you can see, the binary representation is consisting about 32 digits. So if we are using the SQL drawing right here, we have the value from the right side as 1 right here, and don't mind about the previous challenge, and we are starting from the 0. And if we happen to use 2, what about the integer 2? It is equals to the 0, 0, 0, 0 5 times, and then another 0, which is 10 times, 15, 20, 25, 30, and then 32, 31, 32. So that is the binary representation of the integer 2. What about the integer 3? It is fairly simple. It's supposed to be like this. Let me copy this part to shorten our work. And this is binary of 2, and this one is binary of 3. Oops, this part is 3. And what is the correlation to solve the challenge about the LeetCode challenge? Using the of the single number 2 right here, we can use the every column of the binary of it, or every bit, we can use the modulo 3 to solve this out. and we count every value separately or individually by their column individual result, and we can just return and filter out using the modulo tree to see which one has the remainder of 1, and we can just return the result as the integer representation of the resulting binary using the resulting binary right here of the variable. And we can declare a for loop using the for loop to represent the integer as the bit position using the let I is equals to 0 as long as I is below the since I is considered a bit position and it is considered as 32 bits, then we can just use this 32 bits right away, and we can use the I++. And inside of the for loop, we can use the let variable of the bit count, and we can declare this value as 0. And that way, we can use the for loop for of the num of nums using the constant num of nums, and that way we are iterating the number integer, not number integer but the nums array as the individual value of num, and we iterate over the every num. Then we can count the bit by bit to see the result without using the carry, using the bit count and then plus equal sign, then using the num, and then we shift the digit using the bit count that we are currently operating on using the current I shifted to the right is based on the number to the right. So it means that let's say we are operating on the value of 2. If we happen to shift this by 1, then we have the result of, let's say we have the binary of 0, 1, 0, which is represented as 2. If we shift the num, which is the integer of 2, then we shift this by the I, by the value of I. If we have the for loop of the current I of 1, let's say we have the I of 1, I equals to 1, then the resulting will be 0 and 1, and the 0 on the right is going to be eliminated, and we are adding another 0 to the left, and that way we have the result of 1. So that is the usage of the shift operator to the right. And then don't forget to add the bitwise AND operator of 1, and that way we are filtering out the rest of the column. Let's say we have the value of, we have 0, 1, 0 with the value of 2, and we have another value of 0, 1, 1 with the value of 3. No, not this 3, not yet. And we can just eliminate this part and forget 3 for now. And let's say we are shifted this by 1, and we have the value of 0, 0, 1, and the transform result will be 0, 0, 1, which is the value, integer value of 1. Then we use the bitwise AND operator of 1. Then the bitwise operator of 1, then we calculate this as 1, and the resulting value will be 0, 0, 0, not 0, 0, 0, but 0, 0, 1, since on this column, on the right side column, we have the value of 1, and the bitwise 1 right here with the AND operator. Don't forget, use the AND operator. It is I'm using the parentheses to mark since we are using the AND operator, and that way, since they are both 1, then the resulting output is going to be 1. If it is 0, then the result will be 0. If it is, let's say, if we have value of the 13, then the 13 is considered as 1, 1, 0, 1. It's because on the first one right here it's considered 1, and the second 0 is considered 2, but it's not registered. It's not currently being registered. Then it is still 1, and this one is 4. Then 1 plus 4 is equals to 5. Then finally it is 8. 5 plus 8 is equals to the 13. So this is the binary representation of the integer value of the 13. If we happen to shift this by 1, then the result will be 0, 1, 1, 0, because 1 right here is already being eliminated. It is supposed to be 1, 1, 0, but for the sake of the digit completion, we can just add another 0. But if it is a negative number, which is the complement 2, then we have to insert 1 to pad this from the left based on the last digit of the left side. So since it is a positive number, then it is going to be 0. Then we can add the bitwise AND operator of the value of 1, integer 1. Then the resulting output will be 0, 0, 0, and 0. Why? It's because 0 with 1, since it is an AND operator, not OR operator, then the resulting output will be 0. Then another 1 with 0 will be 0, another 1 with 0, result will be 0, and 0 with 0 is the output is 0. So that's not going to make sense for now, but for the sake of the challenge, let's follow around this. And then finally we can declare the result using the equals of the current result and using the bitwise OR operator of the current bit count. In bit count, I forgot to use the parenthesis, and is the modulo 3, the remainder 3, and let's say the bit count is 3. If it is divisible by 3, then the resulting output will be 0, and then we need to shift this based on the current iteration of the I, because we are operating on the bitwise level using the for loop to operate this on each column of the binary operation. So, and for the final one, we can just return our result. And let me draw this using the escalate row in the array of the 2, 2, 3, and 2. Oops. And we have the value of 2, which is 1, 0, and the 3, which is 1, 1. Let me write this again using the 0, 1, 0, and the next one should be 0, 1, 1, and the next one should be 0, 1, 0, and the next one should be 0, 1, 0. Let's say the 3 is placed on the second position of the array, which is the value of 2, 3, 2, 2. And for the first operation of the bit count, we are declare this as the 0, and using the for loop for constant num of nums, using the bit count of the num of the current, and then shift this by the based on the current for loop, shift this to the right by the number of the bit that we are currently working on, and then use the AND operator by 1. And then that way we are converting 0, 1, 0 into, let's say we are on the iteration of the 29. This one is 30 and this one is 31 because it is 32 bits and the array is starting from the index 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 31. This is index 31 and this is index 30. Since it is on index 30, then we need to shift this by 30 and we got the result of 0, 1. And then finally using the AND operator of the 1, then we got the result AND operator of 1, then we got the result of 0, 1. And for the next one, we have 0, 1, 1, and then it will be 0, 1. Using the AND operator, we have the value of 0, 1, then the result will be also 0, 1. It's because on the one right here is going to be padded to the right, then it will be removed, this one will be removed, and this one will be processed, this part of the bit. And for the next one, which is 0, 1, also the same thing with this part, we can just copy this out and we have the value of the 0, 1. Then for the current bit operation, we have the value of 0, 4. The value of 4, the current bit count is 4, then the result will be, since the result is 0, then it will use the OR operator because we are adding the integer operation in a binary. Using the result, the current result, and then using the OR operator of the bit count, and then get modulo by 3 and then shift this based on the number of the current iteration of the bit. Then it should be like this, and then this is 4, and then use the modulo of the, since it is 4, then the resulting bit is 0, 0, 0, and then using the bitwise operator of 4, since 4 is being processed by the modulo 3, then 4 modulo by 3, then the result will be 1, which is the same as 000 and then OR operator of the 0001, and then we need to shift this back to the current bit operation using the double left angle brackets by the number of I of the bit count, not the bit count but the bit operation that we are currently in on the for loop operation. Then since it is 1, then we shift this to the left by 30, back to the 30, then the result will be 0 0 1 0. What about the next one? We have the last iteration, which is the same thing as since this part is the I on the state of the I equals to the 30, and also this part is in the red color. To minimize the confusion, I'm going to write this as red color and then copy this part and write another as blue color. Let me move this part out of the view and don't mind this part, and we can recolor this as the last iteration of the 31. Since 31 should be 1 0 and this one is 1 1, this one is 1 0 and this one is 1 1, then it will be shifted to the right side by the number of the I, then the resulting output should be 1. And I forgot to tell you about this part. We are eliminating the 0 because 0 is on the last digit, and we are only processing this part of the bit, and these are the part of the bit from this part using the shift by the number of the current bit of the I, and then use the AND operator of 1, and we got the result of 0 1. And for this part we still have the 0 1 0, but since we are working with the bit of the 31 or 31st bit, then we are basically highlighting this part, which is the last index of the bit. And the same thing goes to the 0 1 1 right here. We are highlighting the 1, and this one we are highlighting the 0, and this one we are highlighting the not the 1 but the 0, because this one is on the last element of the bit representation. And we have the result of, since it is 0 0 0 or just 0, and then using the AND operator, I'm using the representation of bit in the AND of 1, then we got the value of 0 0. And since it is 1, it is noted as the binary of 0 1. Using the AND operator, we got the value of 0 1, and this one is 0. Since it is 0 0, same as the first one, because we are working with the same number with 2 3 2 and 2, then we have the result of 0 0. Oops. And this part is 0 0. And for the 0 0 right here, it should be 0 0 1 0, is because on the result is already stated as 0 0 1 0, is in the OR operator right here. In the 0 0 1 0 OR is in the result right here, result OR operator of the bitwise OR, and then the bit count modulo by 3, and then after that we need to convert this into a binary representation, and we need to shift this back to the proper placement of the is in the I right here, because we already shift this to the right and we need to shift this back to the left. And since it is 0 0 1 0, then the value of the resulting output is, since it is 0 1 0 0, then since this one is highlighted on the last part, we have the value, and this one is only the one number, since 1 1 1 1 on the previous one on the iteration number 30, then we have the total sum of 4. Since this one is only has 1 0 1 0 0, then we need to return this as 1. With the modulo of 3, we got the value of 1. It's because 1 is non-divisible by 3, then we got the remainder of 1. Then we need to use the OR operator of the result, and then use the 1 again of the binary representation of from the modulo operation, and then we need to shift this by the I, which is the 31 right here. And since it is going first, the 0010 with the 0001, then the resulting output should be, since on the 0 with 1. Since it is using the bitwise OR, then the result will be 1 on the last digit. And on the second digit from the last, we have 1 and 0, then the value will be 1. This last digit is 1, is in the bitwise OR, don't forget. And this one, since it is 1 and 0, then the second digit should be 1 because it has at least 1 on each operand. If they are both 1, then the result will be 1. And if it is 0, if they are both zeros, then the resulting output will be 0. That is the neat use of the bitwise OR operator. And then we need to shift this back based on the bit count, which is the 31. And then we got the result of the 0011. And if you notice 0011, what is 0011? We need to calculate this from the right. Since 1 is 1, then this 1 is 2. Then of course we got the value of 1 with 2, value of 3. So that is the final resulting of the value. And using the JavaScript, and I don't know about something else other than JavaScript, if we happen to use the result variable right here, it is also represented only not as an integer but as an also as a binary, because an integer is resulted by from the binary, so the binary will be, it is already calculated before the integer variable right here. So if it is 0, then the other value under the hood is also 0. If it is 2, then it should be 0010. Then the resulting output is automatically converted back to the desired number, which is 3. So let's run the code again to see if it works. So I'm sorry about the long explanation, but I was also struggling to explain all of this because yeah, I'm still a beginner. So let's submit our code. We have the unknown network error, lower runtime possible, unlike using the hashmap, and we have the memory complexity, but I don't always believe in this part because it is kind of redundant. So that is the second operation, or the second way how to solve the particular LeetCode challenge of the single number 2. So that's about it. I hope you understand my explanation. If you still understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.